I'm going to demonstrate a simple motor. If we have a loop of current, we define a magnetic dipole moment as the product of that current, the cross-sectional area of the loop that the current is going around, and we give it a direction. And the direction is defined by this unit normal to the loop, where if you put the fingers of your right hand in the direction the current is going, your thumb will point in the direction of this unit normal. Now if we put this current loop in a magnetic field, it will experience a torque, and that torque is given by the cross product of the magnetic dipole moment and the magnetic flux density. So the loop will rotate until the magnetic dipole moment is in the same direction as the magnetic flux density. So the torque will go to zero when the loop has rotated, so that this little unit normal, A sub n, is pointing in the direction of the magnetic flux density field B. Okay, here I've taken a piece of wire and looped it several times. So if I pass a current through this wire, it will go around and generate a magnetic dipole moment. And the magnetic dipole moment actually increases with the number of loops. So a 10-loop coil will have 10 times the magnetic dipole moment of a single loop coil. Okay, so now in a motor, what happens is you place a coil like this in a magnetic field and current flowing through it, so it will rotate until the magnetic dipole moment of this coil loop aligns with that of the magnet. And then the rotation would stop because the torque will have gone to zero. But what happens in a motor is something called commutation. So at that point, the direction of current is reversed through the loop. So the magnetic dipole moment flips, and so again you have a torque which will rotate the loop until it lines again. The current through the loop switches, and so that's why you get continuous rotation. Now what I have here now is a battery with just a couple paper clips so that I can pass a current through this loop by laying it against these paper clips. Now I don't actually get commutation. What I've done is I've just removed the insulation on one side of the wire here, so that when it rotates and the magnetic dipole moments align, the current stops because now the insulation is touching the paper clip, and momentum will carry the loop around. And the magnetic field is generated by this stack of magnets that is going to be sitting right here. Okay, so now let me stand this up and attach the loop, and we'll see how it rotates.